So this was given to you last time as your homework. If you recall, we had discussed how we would find cos A or sine A from cos 2A, if you recall. So I drew the diagram that's in the yellow, solve for x. Remember, x is in this, well, the point the terminal arms come to rest in the second quadrant, so x is negative. So that meant that cos 2 theta was equal to negative 8 over 17. And I solved for cos theta by using cos 2 theta equals 2 cos squared theta minus 1. Subbing in my minus 8 over 17 and then solving for cos theta. So adding 1 to both sides, dividing both sides by 2, and then eventually taking the square root. So that's what I ended up with as my answer. Cos theta is equal to root 9 over 34. Okay, Hlobi used to on holiday. Cool beans. Okay, so that was my answer. Are there any questions about this matrix? Any questions, matrix? No? No questions? Nope.
Oh,
All right.
nailed it. I wonder how many of you got it right.
Who tried it and got it right?
Yeah.
Who tried it and got it right? Anybody tried it and got it right? Tegofatso, do you have a question? Oh, are you saying yes for you, or do you have a question, Tegofatso?
Ma'am, I have a question.
Sure, go for it.
Ma'am, isn't that answer supposed to be negative root 9 over 34? Because it's the diagram lies in the second quadrant, right? So isn't it supposed to be negative?
It's funny actually that you asked that, because after I had drawn the diagram, I went back and I went and had a look. But remember, what you are solving for is cos theta. You're not solving for cos, and I mean, we did make cos 2 theta negative when we were working in the second quadrant. And you're right, when we take a square root, it should always be plus or minus. But what we have done is we have halved the angle, isn't it? We couldn't halve the ratio, but we've halved the angle. So the angle has gone from cos 2 theta down to cos theta. So if we halve the angle, our final answer, where are we? Are we in quadrant 1 or in quadrant 2 if we halve the angle?
Isn't it quadrant 1?
Exactly. So isn't cos theta positive in quadrant 1?
Oh, it is. Oh, I see, ma'am.
Okay, I agree with you. I also went back at the end and I said, okay, my answer can be positive or it can be negative, but I've halved the angle. I haven't halved the ratio, but I've halved the angle. So if I halve the angle, even if my so then I have to be in quadrant number 1, okay, where cos theta would be positive. Okay, so that's why I said the answer was positive and not negative. No problem. I think it's a very good question. Well done for asking. Okay, all right. Well, if there's no further questions, then let's jump in and do ratio in terms of a letter. This is actually our second to last lesson on trig. So what I'm going to do is go through an example of ratio in terms of a letter, and then I've got an example for you guys to try. Remember, in this section, we're going to be using compound angles, as well as our double angles, as well as our reduction formulae. We can also use co-ratios. So you guys need to be on the lookout for all those sorts of things when you answer questions like this in tests and exams. Okay, let's have a look at the first one. So here the example is the cos of 25 is equal to k. So when you are doing ratio in terms of a letter, the angle that you are going to be working in terms of is always going to be an acute angle. So because it is an acute angle, you're always going to be working in the first quadrant. All right. So unlike the questions on Pythagoras, when we're talking about ratio in terms of a letter, You do not need to worry about which quadrant we are in because, oh, that's not a very nice one, because we're always going to be in quadrant number 1. Okay, so it's a little bit different to ratio in terms of a letter, but it still involves the theorem of Pythagoras. The difference is that we are only working in the first quadrant when it comes to ratio in terms of a letter, not like the other ones. Okay, so if I were to draw a diagram, my terminal arm would come to rest somewhere over here. There would be my angle of 25 degrees. And then remember, I interpret sine theta as y over r, cos theta as x over r, and tan theta as y over x. So if this is the cos of 25 degrees equals k, that means that k is k over 1. So in other words, k is our x coordinate and r is the length of the terminal arm. So r is equal to 1 in this case, and the coordinate at the end of the arm over here is k, and we don't know what y is. So we're going to use the theorem of Pythagoras to determine y. So subbing into x squared plus y squared equals r squared, we would end up with k squared plus y squared equals 1 squared. And that means that y squared would be equal to 1 minus k squared. And because I'm working in the first quadrant, y is going to be positive when I take the square root. And this would give me 1 minus k squared. So now, before we carry on, I just want to have a small discussion with you. Can I drop the square off the k because I'm taking a square root? Is that allowed? Can I drop the square off the k? Is it okay mathematically for me to do that? Good. I'm so glad you're all saying no, it's not. Good. No, it isn't. Right, you're quite right. I cannot drop the square off the k. That's because I cannot separate k squared from 1 minus from the other term. So no, definitely not. So be careful of that. Also, if I wrote my answer the wrong way around, so what if I got down here and I said y equals root k squared minus 1? Would that be okay? Is it okay for me to swap the order around? Is that allowed? Good. All right. I'm so glad to hear you all saying no. Yes, lovely. All right. So that's not allowed either. Okay, that would be wrong too. Okay, so no swapping the order unless I'm going to write minus k squared plus 1. So, and I can't drop the square off the k either. Good job. All right, so let's jump into the questions now that we have done the diagram. The first one, the cos of 155 degrees. All right, so here, what do you think we should do, Matrix? What would you do first? Anybody want to tell me? Okay, I see there's a couple of, okay, Tsachafatso, go for it. What would you do? That's it. Okay, so you put that into the chat. So Tsachafatso said you would reduce the angle. Absolutely. We would use our normal reduction formulae, 180 minus, and this would reduce to negative cos 25. So just be careful about the negative. If you're saying 180 minus, it's quadrant 2, so you would reduce it to negative cos 25. You know that k is equal to the cos of 25, so this would be equal to negative k. So that one's quite easy. 1 mark for reducing, 1 mark for our answer. Second question now, Matrix, the cos of 50. Anybody want to tell me what you think we should write now? What would you do here, Matrix?
Double angle.
Double angle, quite right. Does it matter which one I use, which cosine double angle I use? Tsechofatso, I don't know if your hand was up from the last time. You're welcome to unmute if you want to. quite right. It doesn't matter which one you use. My favorite is 2 cos squared 25 minus 1. And now we're going to go and sub in. Okay, so we know that the cos of 25 is k. So cos squared 25 would be k squared minus 1, like so. And again, a mark for expanding and a mark for subbing in. All right, question 3 is actually the easiest out of all of these. We've actually already got the answer to this, the cos of 25. So we know what the sine of 25 is from our diagram. So we know that it is equal to root 1 minus k squared, like so. Okay, we can write over 1, but if we don't, we're not going to get penalized for that. And the marks for this question would involve the diagram, the identity, and then your final answer over there. Okay, and then the last one, the sine of 50. So hopefully all of us are thinking about our double angles again. Very important that you write 2 sine 25 cos 25. Okay, you're going to get marks for that. You've got to write what you get when you expand or reduce in trig. Okay, so you're going to get a mark for expanding and now another mark for subbing in. So this would given us 2 times root 1 minus k squared times k, and then convention dictates that we would just put the 2 monomials essentially at the front and then the root at the back like that. Okay, and then that would be our last mark there. All right, any questions, Matrix? Any questions on this? Is it making sense to everybody? Lidwina?
Hi, ma'am.
Hi,
How are you?
I'm fine. How are you?
I'm good, thanks, ma'am. I just wanted to ask if we could slow down a bit. It's my first time learning this, so I just want to catch everything.
Okay, so Lidwina, are you new to Watobe?
Yes, I am, ma'am.
Okay, all right. There, shame. I'm so sorry. This is going to be very, very difficult for you because everybody else has had 2 lessons on compound angles, 2 lessons on double angles, plus a lesson on Pythagoras. This is actually the second to last lesson in this particular course. So it is going to be very difficult for you to understand what it is I'm doing here. Have you done trig at school? Have you done
Yes,
trig? Have you? Okay.
I
All
have,
right.
ma'am, and I've also watched the previous lessons that you taught. It's just
Oh,
my
did you?
first hearing of using the letter, so that's why I'm a
Oh,
bit
okay.
confused.
Or no, that's fine. Did you do ratio in terms of a letter last year in grade 11? You should have, but not with compound angles or with double angles.
Yes, ma'am. I think that's why I'm a
Okay.
bit confused.
Okay. All right. Okay. Well, hopefully that made sense. I am going to give you an opportunity to practice this and try this as well. That's going to happen right now. Okay.
Okay, thank you, ma'am.
All right. No problem, Lidwina. Okie dokes. So now, and then also take screenshots, guys, because that's going to help you in terms of the answers as well. All right, what I'm going to do is I'm going to get you guys to try this particular question. Okay. And what I'm going to do is I'm going to go and grab this guy. And I'm going to bring it down here. Let's put it over there. All right, so Matrix, you're going to try this question now. Right, make sure you draw the diagram and make sure you calculate the variable that's missing in terms of k before you carry on with the rest of the question. Right, if you get stuck, then remember Yolanda and I are here to help you. Okay,
Right.
all right. Yolanda, I'm just gonna, my chair's broken. I'm just gonna get my other chair. Just give me 1 second, okay?
That's
I'll see you
fine.
now. Thank you.
Let's do this, my people. Let's do it. Lidwina, is that like a hand to ask a question? Or you're okay?
I'm okay, ma'am. I just forgot to lower it.
Okay, no problem. No problem. Let's go, guys. Remember, we have the compound angle formula there and the double angle formula. So we are good to go. We are definitely good to go. If you can draw your Cartesian plane and just draw where your right angle triangle is, you'll be just fine. You guys are doing amazing work. We can do this. Oh, we're going all the way until E. Believe?
We are indeed. We are
We are
indeed.
doing this, my people. But I think once they have that triangle where they know it is, I mean, then it becomes faster to answer the questions.
It does. It does. Okay, I see Tsepang was saying, can you explain question 3 again?
Raphael, don't worry. We just really started now. You'll catch up. Just try the questions on the board and let's see how far you get.
Oh. Okay, so Nolutando is done. Okay, Everybody else, don't rush. It's okay. Yes, we're doing all of them, Einstein Jr., from A through to E, because this will help you practice all the different types of questions that they could possibly ask when it comes to ratio in terms of a letter. Okay, you're doing all of the questions from A to E by yourself, and then we're going to mark it. Well done, Lorato. Okay, so Katlejo, you're just going to have to hang tight, and you'll see how we do this when we go through the answers. Everybody's just working on this by themselves. Well done, Penga. Well done, Kagisto. Well done, Artile. Good job. Asinel is done too. Jessica, Klaar. Okay, Jessica. Very funny. Oh, Bonga's giving us a skull. All right. Almost done. The city's done. Labels done. Offenses done. Trish, you done. Cool. Ethel, what are you saying? Doubtful about D. Okay, Ethel, that's fine. We're going to go through all the answers together. All right, so I've had a response from quite a lot of you by now. So I'm just going to get rid of that. And let's get started. All right. So the first thing, hopefully, that you guys would have done here is you would have drawn yourselves a little diagram. Okay. Let's get a diagram going. And we know that we're in the first quadrant because our angle is only 12 degrees. And if they've given us the sine of 12, then what they are telling us over here is that k over 1 is y over r. All right, so you should have said that r is equal to 1 and that we don't know what x is and y was equal to k. So we should have solved for x in terms of k using Pythagoras. This would have given us x squared plus k squared is equal to 1 squared. So x squared is equal to 1 minus k squared, and therefore x is equal to root 1 minus k squared. We're not going to drop the square on the k, and we're choosing a positive answer because we're working in quadrant number 1. Are we all good up to this point? Did everybody do this?
Ma'am, can you please repeat that again?
Okay, so Katleho, we were just working out what our x coordinate is in terms of k. All right, so using our diagram and then subbing into the theorem of Pythagoras and then solving for x in terms of k. Right?
So is that like sine theta? No,
So
ma'am.
so the sine of 12 is k. All right,
Yes,
so
ma'am.
if they've told us that the sine of 12 is k, remember sine of any angle is going to be y over r. So they're telling us that the y coordinate is k and r is equal to 1. So we need to work out what the x coordinate is in terms of k. All right, and that's where we get, using the theorem of Pythagoras, where we get root 1 minus k squared from. Okay, Lidwina?
Okay, ma'am.
Ma'am, I just wanted to ask if we'd get a mark for this diagram and the correct
Yep.
working out of x.
Yes, absolutely. Absolutely. Because you need this information in order to be able to continue. So often what they do is they either give a mark for the diagram or they give a mark for the identity. Okay, but yes, absolutely, you're going to get a mark for that. Okay, so it is important that you go ahead and go and draw it and then use the square identity or the theorem of Pythagoras in order to be able to work out what x is in terms of k. All right, now moving on to the first question, they asked us for the cos of 24 degrees. Oh, I see there's more questions. Hang on a second. Lidwina, did you still want to ask something? Or is your hand just still up from earlier?
I'm fine, ma'am. I keep forgetting to put it.
Okay, no, that's fine. No problem at all. Katleho, do you want to ask something?
Ma'am, I actually want to respond to question A, and I think
Go
it
for
is
it.
wrong. So, ma'am, I want you to correct me.
Okay.
So, ma'am, my answer is like, I give you, sorry, ma'am. So it is 1 minus 2 sine squared 24.
Okay, not 24, 12.
Why,
Okay,
ma'am?
okay,
Because like
because
cos is 2.
yes, exactly. So in other words, cos 2a is 1 minus 2 sine squared a. So you've got to halve the angle, don't you? So if you've got cos 24, you're going to have 1 minus 2 sine squared 12, aren't you?
Oh, okay, ma'am. So this is where I
Okay.
went wrong.
It's okay. All right.
First step. Okay.
Okay, but that's okay. This is how you learn. Don't be upset about it. Don't make yourself feel bad about it. This is how you're going to learn. Now that you've figured this out now, you're not going to keep making the same mistake over and over again. Okay, so now you've got 1 minus 2 sine squared 12. Now remember, we're working in terms of 12 degrees. So now all you need to do is go and sub your k in. So now you would have said 1 minus 2 sine squared 12. The sine of 12 is k. So we're going to sub in our k, and then we need to square it. There you go. Okay, so that's the answer to the first one. Okay, so the cos of 24 is equal to 1 minus 2k squared using our cosine double angle. Okay, we're getting there, we're getting there, we're getting there. Okay, next one. Now here, they are asking us for the sine of 24. So anybody want to tell me what they got here?
Ma'am, can I please try this one?
Sure, Ludwina, go for it.
Okay, so I identified sine 24 as a double angle.
Cool.
I wrote it as 2 sine 12, cos 12.
Lovely.
So
Okay.
then for 2 sine 12, I had 2k.
Mm-hmm.
And for cos 12, I had the square root of 1 minus k squared.
Very nice. Well, for someone who hasn't done this before, you certainly seem to be doing very, very well there. So that's excellent. Well done,
You're a
Ludwina.
good teacher, ma'am. Thank you.
Oh, it's not me, my darling. It's all you. Well done. Okay, that's really nice. Good job, Ludwina. Nolitando,
Okay.
you got a question?
Hi, ma'am. No, I just wanted
Hi,
to ask if I can
Nolitando.
do C.
You want to do C?
Yes.
Oh, beautiful. Go for it.
Okay,
What did you
ma'am.
do?
So I use the interior angles of a triangle. So 180 minus 90 minus 12 is 78.
Good. Okay.
And then from there, sine is opposite of a hypotenuse. So our
Okay.
x is going to be our hypotenuse. So it's going to be square root 1 of minus k squared over 1.
Okay. Now, I just want to stop you there. Everything that you have said is perfect, but I want to just get that down on paper. All right.
Yes,
I
ma'am.
love the fact that you looked at this and you looked at this and you realized that you had to use 90 plus or 90 minus. Okay, because if we add 12 and 78 together, we end up with 90. Now, because you said 180 minus and then you said 90 and then you said minus again, this means that you're going to be using a co-function. All right. So when you are using a co-function, it means that sine changes or sine theta changes to cos theta and cos theta changes to sine theta. So what I want to just first formalize is that when you wrote down the question, you would have said that this was equal to the sine of 78. Then over here, what you should have done is said that this was equal to the cos of 12 because of 90 minus. Did you do that?
No, yes, ma'am, because I wrote
Okay.
it as interior angles and then I did it as a co-function.
Okay. All right. So from you writing cos 12, now you can tell me what was the rest of it. What did you have?
So cos is adjacent over hypotenuse,
Mm-hmm.
and then which is going to be root 1 minus k squared over 1.
Perfect. Very nice. Well done. That's 100%. Good job.
Ma'am, I have
Thank
a
you, ma'am.
question.
Well done, Nolitando. Yes, Ludwina, what's your question?
I don't know how to word this, but I'm gonna try. So basically, when we have like reduction, but it's less than 90 or it adds up to 90, then we have to use co-ratios.
Correct. So you must
Okay.
always be, so you must always be on the lookout for co-ratios. They like to use them in matric a lot, and then it's something from grade 11. So because we've forgotten about it from grade 11 and we're not thinking about it and we're just thinking about double angles and compound angles, it makes the question actually a little bit more difficult, but it's not meant to be. It's not meant to be more difficult. But yes, so if you look at the 78, you'd look at the 78, you'd look at the 12, you'd say it adds up to 90. Because those two angles add up to 90, that's your clue that you have to use co-functions. All right, so just a quick revision of this for you guys. If you have got the cos of 2 degrees, it's equal to the sine of 88. So sine can be written as cosine. All right.
Okay, so ma'am,
Vice
if it was
versa.
an angle bigger than 90, then it would use reduction. But if it's less
Correct.
than or equal to 90, we use co-ratios.
Yes,
Okay, thank you,
perfect.
ma'am.
No problem. Perfect, perfect, perfect. Okay, let's just see what's going on in the chat.
Ma'am, I have a question.
Yes, sure, Tsegofatso.
What if I just write the answer instead of writing cos 12 there? Just write straight the answer.
You're going to end up losing marks, okay? And it's going to be
Okay.
not because your answer is incorrect. You'd get the mark for your answer. But let's say that this question was out of 2 marks. Let's say you'd get 1 out of 2 instead of 2 out of 2.
Oh, okay, okay.
Okay,
Because I
so
used the sketch. Like my sketch, I wrote inside the triangle there is 90, then there's 78, then there's 12. So I just used the opposite.
that's fine. Okay, so then did you, in your sketch, it's okay if you do that. Let's say you did you label that this angle was 78 degrees over here?
Yes. Yes.
Okay, then that's absolutely fine. You'll get all the marks. Okay, that's absolutely
Okay.
not a problem for you to do that, but you must label the angle, as I've said to you over there. And if you label the angle over here, then you can actually go straight from there to there and you'll get all the marks. Okay, not a
Okay.
problem, Tsegofatso. So I'm glad you actually brought that up. Okay,
Yes,
well
thank you,
done.
Question.
Jessica, do you want to ask a question?
Yes. Do we get a mark for writing the numerator and the denominator here?
I would say, you know what, you probably wouldn't worry about writing the denominator, to be honest with you. It would be for writing the numerator, not the denominator.
Okay. Thank you.
Okay, all right, Jessica, no problem. Let's just see if there's, okay, so that was Jessica, sorted out. Any, let's just have a look at the chat. You do. Einstein Jr., yes, you would use compound angles. Ethel, you're asking, is it okay if you didn't use co-ratios? Ethel, you'd have to use co-ratios. I don't know how else you would answer that question if you didn't use co-ratios. What else could you do? I'm just trying to think. Because you see, you can't use a compound angle because your angle's in terms of 12, isn't it? So it wouldn't even help you. It wouldn't help you to use compound angles. Yeah, the 78, that's what I'm thinking about, Ethel. So how did you do it then? What did you write? If you didn't use...
on my sketch, like,
Oh, okay, like Tsegofatso.
yes, no.
Okay, all right. You see, well, then you see you still are using co-functions because it's still, you're saying 12 plus 78 adds up to 90, which is the remaining angle. Okay, cool, not a problem. So if you use a sketch like Tsegofatso, as long as you labeled your angle, it's absolutely fine, not a problem. Okay, so Einstein Jr., you've been thinking about the sine of 42, and now you said you think it's a compound angle, so that's perfectly correct. What would you write? What did you write? What do you think you should have here? Einstein Jr., I'm asking you if I may. Okay, Nolutando's put a hand up. Okay, Nolutando, go for it.
So it's a compound angle. So if you take 30 plus 12, it gives you 42, and then 30 is a special angle.
Good. Okay. Now, Nolutando, that's perfect. What you said there is 100% correct. Make sure that you show that you've expanded this, okay? Because you're going to get marks for that. So sine keeps its sine. So you would have written sine 30 cos 12 plus
Cos 12, cos 30 sine 12.
Beautiful. Well done. 100%. Okay. So matrix, you're not going to get a mark for this line over here. You're not going to get a mark for that, but you're going to get the mark for this. Okay. So that's why you've got to make sure that you wrote it. Okay. And then as you had said, using our special angles. So the sine of 30 is a half. The cos of 12 was our root 1 minus k squared. And the cos of 30 is root 3 over 2. And the sine of 12 was k. All right. No, that's fine, Einstein Jr., not a problem. Hopefully you've got all of this. And then here, these are not like terms matric. So don't worry about trying to simplify something like this. You actually are finished when you get to that line over there. Okay. There's no sort of further simplification that can take place. Yes, Jessica, go for it. You're welcome to unmute and speak.
What I did is that I saw co-ratios, right?
Mm-hmm.
I said 90 minus 42 and I got cos 48.
Okay.
From there, I saw a double angle.
Okay.
Then I said cos 2.24. Then
Let
I
me
saw
Okay, so the first thing that you did is you said the sine of 90 minus 48 is the sine of 42. Then you would have had to write this as the cos of 48. You did that, hey?
yes, I did.
Okay, all right. And then you said that this is a double angle. So you said 2 times 24. Okay, keep going, Jessica.
And then I saw another double angle in the 24.
Let's just move that out the way there. I was playing with that earlier. Okay, so then here you would have had to write this. Let's say you decided to write it as 2 cos squared 24 minus 1. What did you do then?
Then
Or hang on a second, did you end up doing something like this?
yes, but I was now stuck because there's a 4 there.
Yes, absolutely. Absolutely. So I would say, I mean, I would get stuck at this point as well, because you know, this is now it's double of a double angle.
Yeah.
I've never seen something expanded to this point before. I wouldn't do it like that. I think that, you know, doing it this way, it's what you've written here is not necessarily wrong, but with the information and the compound, with the double angle formulae that you've got, it then makes it very, very difficult for you to proceed to find an answer. So that's why it's kind of easier for you, to be honest with you, if you just stick to the traditional methods of doing things, then you're going to find you're going to get to the answers a little bit easier. Because, yeah, I mean, you want it in terms of 12. So, I mean, if you wrote this as 2 times 2, yeah, you see, you just can't write it in terms of the double angle that you're actually looking for. So, yeah,
Yes.
I would say in this case, yeah, I definitely wouldn't do it this way. Okay,
ma'am.
it's not necessarily, what you've written is not necessarily wrong, but it doesn't help you finding an answer. Okay.
Thank you, ma'am.
All right, let's see who else has got. Katleho, you got a hand up?
Ma'am, are you talking to me or the other Katleo?
Oh, no, I'm talking to you, Katleho.
Okay, ma'am.
Okay.
Ma'am, cos 48, ma'am, isn't it just going to be double cos 24? Because like we already did cos 24, so we just put a 2 on top of it.
Okay, now hang on a second. If you oh, I see what you're saying. So in other words, you're working from here. So in other words, you've got the cos of 48, but you've already got the cos of 24. Now the problem is though, is that if you double the angle, you can't double the ratio. Okay, it doesn't work like that. Okay, and let's just talk about that again. All right, do you remember at the beginning of this lesson? I think it was the beginning of this lesson. I said, what is the sine of 90? And somebody said to me the answer is 1. And then I halved the angle. All right, but the sine of 45 is not equal to a half. It's equal to root 2 over 2. So if you halve the angle, you're not halving the ratio. Okay, so I can't take the answer for I can't take the ratio of cos 24 and just double it to get the cos of 48. That's not going to work. Okay, or if you look at something else that you already know as well. So if I take the sine of 60, you know that the sine of 60 is root 3 over 2, isn't it? Now, if I halve the angle and I get 30 degrees, the answer is not half of root 3 over 2. The answer is simply a half. Okay, so you've got to be very, very careful of that. If you halve or double an angle, you can't halve or double the ratio because it's not the same thing. And that's because with a sine curve and with a cos curve, you're working along a curve. You're not working along a straight line. It's not linear. Okay, so that's why that unfortunately will not work as well in this case. Right, it's a common mistake that a lot of students make. All right, so I would say here your best option is to go with the compound angle, expand it as the compound angle, and then go and sub in. Okay, but you know what, Matrix? I think it's really cool that you're trying to think of interesting and different ways of doing things. And there often, especially with Trig, there often are lots of different ways in which we can answer questions. But what we've got to do is we've just got to make sure whatever we do has got to be able to lead us to a solution by either applying a reduction formula or special angles or something that we've learned. When we sort of start working outside of that, then we can find ourselves sort of getting a little bit stuck with things. Okay, but well done. I love the way you guys are thinking and trying. I think it's absolutely fantastic. And I'm going to give you a couple of challenging questions that I want you to try for homework. Shame, I know it's homework in your holidays, but we'll see if we can do at least one of them before we say goodbye. Okay, so the tan of 12 degrees. So the tan of 12 degrees, that's actually a pretty easy one. Let's see who had a hand up first. Khomotse, do you want to go?
Yes, ma'am. Can you hear me?
I can hear you just fine.
Okay, so ma'am, I'd like to do number E.
Sure.
I identified tan 12 degrees as sine 12 degrees over cos 12.
Mm-hmm.
And then I substituted it with k over
Okay.
1 minus k squared.
Okay, so you said that the tan of 12 is y over x, and sine 12 was k, and cos 12 was root 1 minus k squared. And that's beautiful. Well done. Very, very nice. Lovely. Fantastic. Okay, so there we go. Well done, Matrix. This was really lovely. I love the way all of you participated and shared answers and contributed to this. That was really, really cool. Well done. All right, now, yeah, you know, it's the same old thing, Einstein Jr. We learn about the graphs at the end for some reason, when really everything relates back to our graphs. And if we're always thinking about our graphs in our heads, I find it just makes so much more sense to me. All right, so yeah, don't forget about the graphs. Remember your sine curve looks like that. Okay, and if 360 is over here, there's 180. There is, sorry, 270. There's 180. There's 90 over there. Okay, and I think it also helps to sort of look at it like this. You know, that's quadrant number 1. Okay, where the graph is positive. Here's quadrant number 2. Okay, it's still positive. Then we get into quadrant 3 over here, and quadrant 4 over there. So if we have a look at this, you can see it's not a straight line, it's linear. So if 60 is over here, you know, essentially what you are doing is you're reading off a value over there. That's where root 3 over 2 would be. Okay, so 30 would be somewhere over here, would be half of 60, but you're not halving the ratio. Okay, so this would be 1 over 2. All right, so you've got to keep that in mind when you are working. Yes, Asanele, you would get a mark for that, but writing it as sine 12 over cos 12 would be better. Okay, but yes, that's fine to do that. All right, let's just get rid of that. Okay, so now we've only got a few minutes left, unfortunately. Oh, I don't want you guys to see that because I was busy playing around with this earlier. Okay, I'm just going to go and stick this over here. Okay, there are 2 questions. I'm going to quickly do the first one with you, but I want you guys to try this one over here as a bit of a homework challenge. Okay, but we're going to do the first one together. Let's see what someone said in there. Okay, all right, so let's have a look at the first one. So we have got the sine of 9 degrees. Sorry, my window is wide open. It's blowing in here. Let's close it. Okay, is equal to k. They want us to determine the value of the sine of 18 degrees in terms of k. All right, so if we were to draw our diagram, like we always said, there's 9 degrees. Okay, so the sine of 9 degrees is k, so that means our y coordinate would be k. Our x coordinate would be unknown, and that would be equal to 1. So working in terms of 9 degrees, we could then work out what our x is, right? So we'd say x squared plus y squared equals r squared. That would give us x squared is equal to 1 minus k squared, like so. What do you think the next step would be? What do you think we would need to do now? So I've worked out, I've worked out what x is. I know that the sine of 9 is equal to k. What do you think the next step is? Double angle, 100%. So what would you write, Pinga? What would you write? Yes, quite right. So
Well, my
sine,
internet is unstable at this moment.
that's okay. So sine 18, you would write this as good, Pinga, to sine 9 cos 9. And you see, this is why your diagram is so important, because now you've got your diagram in terms of 9 degrees. You know what your x coordinate is, what your y coordinate, and what r is. So now you can use that information and go and sub in here. Okay, so this would be equal to 2k root 1 minus k squared. Okay, so you can see there, they didn't have any other questions with it. It was just this one on its own, like a sort of problem solving kind of question. But this was easy now because of the questions we had done earlier. All right, so your homework this evening is going to be to do the cos 55 equals p. And then your job is going to be to determine the value of cos 5 in terms of p. Okay, so think about all your matric work when you answer that question. Hopefully it shouldn't be too difficult, but a little bit of a thinking question. I think you probably want to do the poll now. Yolanda? Maybe Yolanda's, does anybody know where Yolanda is? Has she disappeared? I think she may have done. Okay, I think Yolanda has lost her internet connection. All right, well, in that case, I don't know how to do the poll without Yolanda, which really doesn't help very much. Yeah, she did say her connection was bad. So I'll tell you what, instead of doing the poll, why don't we do this question? So the cos 55 is equal to P. And then I can give you another question actually to try for homework, which will be a little bit more difficult than this. Anybody got any suggestions on how we should do this? Katleho, what would you do?
Ma'am, looking at what you did, ma'am, we're first going to draw our plane, right? And then we're going to say that our x value is P. So this time around, we're looking for our y value. And then we do the whole, yes, ma'am. Okay, ma'am, I'm gonna wait for you to finish the diagram. I don't want to like leave.
Okay, so that's fine. So there's our diagram.
Ma'am, isn't cos like x over r? So isn't it going to be P is to y?
It is, sorry, my beg your pardon. So it's going to be P over here and then Y over there. That's better. Yes, absolutely.
Yes, ma'am. So we're going to say P squared plus Y squared equals to R squared.
Is equal to R squared, absolutely. And you know that R squared is equal to 1.
Yes, ma'am.
So Y would be equal to root 1 minus P squared.
Yes, ma'am.
Okay, cool. All right, perfect. All right, so you've drawn your diagram. All right, and I love that you've got the building blocks of what you need for your answer. So that's brilliant. What are you now going to do with the information that you've got? Because they want you to work out the value of cos 5, right? From cos 55 equals P. So what do you think the next step is?
Ma'am.
Jessica.
Okay.
Okay. Oh, there's Yolanda. Yolanda, we decided
Sorry,
to carry on with
yeah, it's because I'm having load shedding. Then I'm not gonna be able to. I don't know. It keeps on kicking me in and out. Sorry about that.
Okay, that's fine.
I
That's fine.
don't know if
We
I'm
actually
gonna
went.
succeed at the end.
That's okay. We actually went on and decided to do this question because I said I didn't know how to do the poll without you. So.
Oh, sorry, teacher.
No, it's okay. So I was being naughty here. All right.
No, that's fine. At least they were not bored.
I hope not. Okay, Nolitando, go for it. What would you write? What would you use here?
Ma'am, I would use compound angle.
Very nice. What would you
and
write?
I'd say cos 60 minus 55.
Good. Well done. So 60 minus 55 to get your 5 degrees. Well done. That's perfect. Very nice. So now we would go and we would
Substitute.
sub in. Absolutely. Well, we would just expand first and then we can go and sub in. So we would write this as cos 60, cos 55. Cos doesn't keep its sign, so this would be plus, and then this would be sine 60, sine. Sorry. Yeah, sine 55, quite right. And hang on a second.
Please do the poll. Please,
Yeah,
please,
do the poll. Was I doing earlier? Sorry, that's better. So the cos of 5 is the cos of 60 minus 55. That's better. Okay, so cos 60, cos 55 plus sine 60, sine 55. And now we can go and sub in. Okay, so the cos of 60 would be equal to 1 over 2. The cos of 55 would be equal to P. All right, plus the sine of 60, that would be root 3 over 2, and the sine of 55 would be what Katleho calculated for us, which would be 1 minus P squared. Okay, let's just see if there's some questions. Jessica, go for it.
Ma'am, I did it a different way, in a different way.
Okay, all right, what did you write?
I saw co-ratios and said sine 85.
Okay, so where did you get the sine 85 from?
It said
Did you
90 minus
Oh,
5.
okay, so if you said sine 90 minus 5, then remember if you use 90 minus or 90 plus, that would give you cos. Okay, because sine's got to change to cos and cos has got to change to sine. But then your problem is here is that now you're working in terms of 85, but then hang on a second, did you then say
Ma'am,
what 60? Yes,
isn't cos 5 equals to sine 85?
isn't cos 5 equals to sine 85? Yes, it is.
So I instead
Oh, so you
said,
did, so that's what you did. Okay, all right, hang on a second, let's just get that down. Okay, so you said cos 5 is equal to sine 85. All right, keep going.
and then I saw I split it and said 30 plus 55.
Oh, interesting. 30 plus 55. Okay,
And then compound
nice.
angle.
Lovely, no problem at all. Absolutely, you can do it that way. That's really good thinking. Lovely.
Okay.
Very nice. And then you would have obviously expanded it using your
Yes.
sine compound angle and then gone and subbed it. Absolutely nothing wrong with that. I love the way you thought about that problem. That's great. Very nice. Well done.
Thank you.
Good job, Jessica. Very good. Okay, guys. Well, that brings us to the end of our lesson this evening. The question that I wanted to give you for homework, I'm going to give you this one. Okay, so take a screenshot of that.